Section 8.6 is about natural logarithms. You are never ever going to see somebody with a t-shirt that says log base e of x. You won't see it on a billboard. You won't see it in a television commercial. Even though we can have a logarithm with a base of e, you're always going to see it written like this. ln, and then there won't be anything written in for the base, and then x. Now, that means this is base e. Just like with a common logarithm, that's with log and nothing there, you knew that was base 10. ln, with nothing. Every time you see ln, you know it's base e, just like with log, and there was nothing there. Now, so we say natural logarithm. I know that gets confusing. Kids are like, ln, why is it ln? Wouldn't it be nl? Don't worry about it. They just kind of try to keep the same consistency with log and natural log. Okay, here's the exponential form. E to the second power, we know that's approximately 7.389. That's the same thing as the log form of natural log 7.389 is approximately 2. Remember, you're rewriting it into its log form, and you're using the base is e, the argument is 7.389, and the exponent that it equals is 2. We can also look at graphs. Y equals e to the x. We know that's exponential growth because e is larger than 1, right? It's 2.718. So you'll get a picture that looks something like this. Well, what about the logarithm graph base e, the natural log of x? Well, every logarithm, oh, by the way, this is the 0.01. Every logarithm graph looks the same. It doesn't matter whether it's base e or base 5 or base 17 million. All of them have the same basic shape. And they all go through the 0.10 unless something has been shifted or changed on us. So we've got an exponential growth function in y equals e to the x. And we've got a log graph in y equals the natural log of x. Here we had an asymptote of y equals 0. Here we have an asymptote of x equals 0. Those are the lines that it gets closer and closer to but never touches. Now, all of the properties that we've talked about before with other logarithms of other bases hold true for the natural log. So for instance, if I ask you to write as a single logarithm, you're going to do the same thing you did before. You're going to bring the exponent or the coefficient up as an exponent. That's the natural log of 6 to the third minus the natural log of 8. We know that's the natural log of 216. And because I see a minus, that means I'm going to divide the arguments. I know we can reduce that a little bit. Does 8 go into 216? I think it does. 27 times, I'm guessing. But 216 divided by 8. Yep. So this is the natural log of 27. Like I said, all the same properties hold true. We're still going to bring that up here and make this the natural log of x plus the natural log of y to the third. Because this is addition, I am going to multiply the x and the y cubed. So I can write it as a single logarithm. Example 2 is a story problem situation. It says that it's talking about the maximum velocity that a rocket can have is based upon a few different things. The number of seconds that the rocket fires, the exhaust velocity, and the ratio of the fuel tank, or the mass of the rocket with the fuel to the mass of the rocket without the fuel. That's called the mass ratio. So these four things are connected together. And here's the problem. It says if the maximum velocity reaches 7.7, then the rocket can obtain a stable orbit around the Earth. Well, if the mass ratio is 25 and the exhaust velocity is 2.8 kilometers per second and the rocket fires for 100 seconds, the question is, can it obtain a stable orbit? So, it looks like we have everything we need. Here, I'll use my other machine. Negative 0.0098 times 100 plus 2.8 times the natural log of 25. 8.03. That's more than 7.7, so yes, it will achieve the max. It will achieve a stable orbit. Because that's more than 7.7, right? It's greater than 7.7. Example 3 says, so the natural log of the quantity 3x plus 5 squared equals 4. Well, I've already got a single logarithm on this side, so that's nice. I can rewrite this, right? E to the 4th power equals 3x plus 5 squared. Okay. So we need to take our square root of both sides, giving us 3 plus x plus 5 equals e squared. Keep in mind we can have a plus and a minus on that when we take the square root. And then we can subtract 5. So let's see here, e squared squared minus 5. What did I do there? E squared minus 5 divided by 3. So one of my possible answers for x is 0.796. And then we have e squared times negative 1. How can I type? E squared times negative 1. So there's my negative e squared minus 5 divided by 3. Negative 4.1. If I go back to the original problem and plug them in, I should find that both of them work because of the square. That square would take care of the positive and the negative, so I wouldn't have to worry about it. If you want to go back and type it in, use the answer feature, you'll find out that both of them should work. Alright, so we've got the natural log of x equals 0.1. We're going to rewrite it since it's a single logarithm. We've got e to the 0.1 power equals x, which according to my machine, e to the 0.1 power is 1.105 approximately. The next one is also a single logarithm, so we can rewrite it into that form. E to the 21st power, that's a big number, is approximately equal to 3x minus 9. Well, actually, it is equal to 3x minus 9. I'm gonna have to round it up here in a second. E to the 21st, big number, plus 9, divided by 3. So, adding 9 and then dividing by 3 to the 21st plus 9 over 3 equals x, which is approximately equal to 439605247.8. A big number. The next one is also a single logarithm, so I can rewrite it too, right? E to the 4th power equals x plus 2 over 3. So I'm going to multiply by 3 on both sides. I'm going to subtract 2 on both sides. So x is equal to 3e to the 4th minus 2. $161.79. Okay, a couple other ones that we need to solve here. This time, remember, in order to change it to its log form, I've got to get that by itself. So yes, I am going to subtract and divide. Subtract 2.5 and divide by 7. So 20 minus 2.5 is 17.5 divided by 7. 2.5, so we're subtracting this, we're dividing that. So e to the 2x is equal to 2.5. Now that it's in this simplified form, I can change it to its log form, right? The base is e, so I use ln of 2.5 equals 2x. So natural log 2.5 divided by 2. 0.458. This is already isolated, so I can change it to its log form. ln of 30 equals x plus 1. Well, a natural log of 30 isn't too bad. That's easy to figure out. So then we need to subtract what? 2.4. Now you can't see the C there, but this is another problem. So I'm going to subtract the 7.2. So 9.1 minus 7.2 is equal to 1.9. Now that I've got the e to the power by itself, I can change it to its log form. ln 1.9 equals 2x over 5. Yes, it's a fraction, so we can cross multiply. when I do cross multiply, I mean multiply these two, divide by the 2, I end up with 1.605 approximately. Now, a couple of these compounded continuously questions. That would be the Pert Formula. It says the initial investment is $1,000 and is now valued at $1,491.80. And it did this achieving with an 8% interest rate. The question is, how long did it take to do that? So, we started with 1,000. We know that the interest rate is 0.08. We do not know the time, but we do know that it's $1,491.80 right now. I need to divide out the 1,000 first. So, 1491.8 divided by 1,000. Well, we know that the decimal is going to move over. 1.4918 equals e to the 0.08t. Change it to its log form. The base is e, so that's ln of 1.4918 equals 0.08t. And yes, we will just be doing some simple division in order to answer this question. The natural log of the answer divided by 0.08. Almost 5 years. Now, suppose we had invested $200 and today it's worth $315.24 after 7 years. What's the interest rate that I've been earning? Sorry. Also the Pert formula. So the first thing I want to do is divide out the 200. That leaves me with 1.5762 equals e to the 7r. Now we're ready for the natural log, so change it to its log form. Natural log of 1.5762 equals 7r. Of course, we will be dividing by 7. So the natural log of that answer divided by 7. So that is a 6.5%. If R is 0.065, that's a 6.5% interest rate. 6.5%. See you in class.